a lot of the stuff that we have covered throughout the sessions today will be sort of summarized in this final session. Basically, node to cloud platforms for us is a tool that we enable our customers to get to market quickly. And what I'll do is I'll briefly talk about why we do that, what is node to cloud, give you some examples of the platforms or the edge devices that allow the development of node to cloud use cases. So for us, within ON and within the IoT group specifically, when we look at the various verticals that IoT represents and where devices have a play, things like verticals such as smart homes, buildings, applications such as predictive maintenance, lighting, etc. What we want to do is we want to take all of our products and technologies that cater to this market and complement it so that users can develop an end-to-end solution. What we mean by that is, in addition to providing the hardware itself, it'll come with a full software suite along with example code. In some cases, it'll also have an operating system. Most of our devices do run some form of real-time operating system. Where applicable, we have mobile application. These applications are launched on app stores, and we do provide source code to interested customers as well. And of course, we partner with all the cloud providers and make sure that our platforms do connect to the various cloud providers so customers have a choice when they develop and prototype their solutions. What are some of the benefits? Again, the key motivating factor for us to provide this is to reduce product development effort and time, reduce time to market for our customers. In a lot of cases, especially in something which is emerging like an IoT, like an area such as IoT, engineers and designers, they want to experiment. We want to try out things and make that process as easy and as efficient as possible. And that's what these node to cloud platforms provide. And they do this through out-of-the-box tested hardware and software that can connect to cloud. And as I mentioned earlier, these come with several example use cases. Hopefully, it was pretty evident throughout the sessions today that energy efficiency is a key focus area and a core competency of ours. And we make sure that our products that are on these node to cloud platforms also are the most efficient ones. So when customers design products, you will invariably end up with really, really long battery life products in the market. So these are some of the key benefits, some of the reasons why we do this. Again, to reduce the development effort, reduce the time to market for our customers. I know Theo talked a little bit about the RSL sensor development kit. This is an integrated kit or a platform which has our Bluetooth SoC in it, and it has about 10 to 12 different sensors from Bosch. It also has, in addition to environmental inertial sensors, there's also a microphone for some interesting applications that for example, within the space of, within the area of worker safety, the microphone can be potentially used to figure out if the worker is subjected to really loud noises and take some form of an action. And on this platform, it also comes with a mobile application, which is launched on the app stores. And for customers who are interested, we do provide the source, as I mentioned. And one of the things we do, in addition to making this kit itself available to customers, is also we try to take this to almost a market launch through our partners. And the way we do it is, as an example, we take something like an RSL sensor kit. We have partnered with a couple of product manufacturing companies. A couple of them are in Europe. And then we also and those companies invariably have some sort of a tie-up with some back-end cloud analytics partners. And together, we create application-specific solutions. In this case, this one sensor kit has enabled us to target applications such as worker safety, asset monitoring, and elder care wearables. This is just a sample of the applications that we are targeting, but of course, anytime you have a really energy efficient, low power radio and a good mix of sensors, it opens up a lot of use cases. I'll quickly touch upon an example use case on worker safety. I'm not sure if Theo covered this during his session. I wasn't here, but if he has, let me know. Otherwise, I'll just run through this. Essentially, using the RSL 10 sensor kit, one of our partners wanted to develop a worker safety solution, right? And of course, there was a detailed list of goals that we had in terms of ensuring that the product itself achieved this. Key among them was to maximize the device battery life, and obviously that drives the choice of connectivity, that drives the choice of sensors, and also the choice of connectivity protocol itself. We wanted something which was an extremely low power protocol, had decent range. More importantly, it had to be extensible, something that you can apply to different sized factory floors, for example. And also when it came to application layer protocols, we wanted something lightweight like an MQTT. And rest of the stuff is sort of a given for a lot of these kind of applications. So these were some high-level requirements to create a wearable that a worker would put on their helmets or their belts or their vests. And we started designing this based on the RSL 10 sensor kit. Things that we wanted to, basic use cases we wanted to address was a panic button, so that in the event the worker is in some form of distress, he can quickly press it and then there is a response. Any sort of ambient monitoring. If the worker ambient environment is high temperature or high humidity because of the environmental sensors in there, it will automatically trigger an alarm. If the accelerometer detects that there's been sudden change and the person hasn't moved, things like man down could be detected. Several other use cases were developed, and we are very close to launching this as a POC very shortly in Europe. So we did use, for one instantiation, we did use an IBM Cloud and their Worker Insights application. IBM does provide a mobile app also that goes with this device. All of this was, it became easy to develop a proof of concept solution thanks to having a fully integrated RSL 10 sensor kit. All the example, all the firmware, all the software that we provide was heavily leveraged, and the development time was significantly cut short. That's an example of an integrated node-to-cloud platform we have. And the next set of slides, I'll talk about a couple of platforms which are more modular in nature. And these are, this one we got really creative and called it the IoT Development Kit. And the kit comprises of basically sensors and connectivity daughter cards, and actuator daughter cards. All of them plug into a baseboard, and basically this is for use cases where a developer is not entirely sure what connectivity protocol is the best one for the application of choice, or what sensors to use, or what actuators. This particular system allows them to quickly, rapidly test things out. All of them come with a plethora of example use cases, and the use cases target things like smart lighting, environmental monitoring, predictive maintenance, and many, many more. Out of the box, they do come with cloud connectivity. Where relevant, we do have mobile applications on Android and iOS. So this is an example of a kit, or a modular kit, where users can mix and match to create the use case that they want. And these kits can be procured from our channel partners today. What we also do is we also make sure that the kits are compliant with some of the cloud providers' guidelines. We take them through certification. All these cloud providers do have a specific requirement in terms of how an end node connects to their particular cloud. You got to follow their protocols and go through their test suite. We do that again, all to ensure that when customers use these platforms and kits and develop, their solutions are fairly close to getting launched. We make them as near turnkey as we can. Bluetooth IoT Development Kit is yet another modular node to cloud platform. Just like the IoT Development Kit, it also has multiple daughter cards. And you do have daughter cards for sensing. You do have daughter cards for actuation. You do have LED drivers, motor control, BLDC, brushless DC motors, as well as stepper motors. Sensing sensors wise, we do have ambient, proximity, humidity, air quality, some of the sensors that Bosch mentioned, and a couple of others, including this does support the RFID sensors that Theo talked about as well. Again, this is just another example of a modular kit where you can mix and match, create the use case you want, and get up and running as quickly as possible. I just want to show a very quick example. This is one of the things that we had one of our interns do, just to prove it to ourselves that these kits are indeed user-friendly and people can set up the boards and the associated software as quickly and as painlessly as possible. In this case, this setup is where you have a sensing node with an ambient light sensor and a proximity sensor talking to a phone which serves as a gateway. The data gets sent to an Azure cloud in this case, and the data is read by yet another system which actuates LEDs and stepper motors. Kind of seems trivial, but the plumbing that is required to make this happen all seamlessly is all provided with the kit. And with our intern, we had this up and running in less than like 20 minutes. Goes to show that these kits are, we've done a lot of work, a lot of plumbing work. We've already taken care of it. It's set up to let your imaginations run wild in terms of the use cases you can generate and not worry too much about the internal workings of connectivity to clouds and various pieces of hardware and software. Here's another example of a good testament to the energy efficiency and long battery life of our products. And by the way, this is the giveaway you're going to get, not the sensor kit, but this is the giveaway. On your way out, you will be able to pick one. What it is a simple temperature sensor which measures the ambient temperature. It has our Bluetooth low energy SoC as well. And the thing we wanted to do with this thing is we want to push it to the limits. Currently the way it is set up, it measures temperature every 2 seconds and broadcasts it as a Bluetooth beacon. Obviously, the use cases where you have to monitor temperature every 2 seconds are fairly rare. But even in that use case, on a single coin cell, a CR2032, we get over 6 years of battery life. So this is an amazing example of what you can do with really energy efficient solutions. So this particular board also comes with a mobile application, or it can be used with any beacon application from any of the app stores where it continuously reads or it continuously scans for beacons, and then whenever it encounters a beacon, it displays the data that the beacon generates. And this temperature sensor, again, is just like the RSL10 sensor, which had all the different kinds of sensors. This is being leveraged by one of our customers into an asset monitoring tag. I talked earlier about this within the context of connected lighting. This platform, again, is going to be comprised of various sensors, light, motion, gas, and people counting kind of sensors. Lighting, the power to the lighting itself is via either an AC to DC or a PoE, various connectivity modalities, including BLE, Zigbee, PoE. So this platform, the connected lighting platform, as we were discussing in the morning, which is becoming fairly foundational, is going to be launched fairly soon. And it also supports energy harvesting switches. And we hope users and customers can pick this and come up with very creative and interesting use cases. Out of the gate, it'll be set up so that there's a mobile application it can communicate with, and the data can be sent to the cloud for any sort of analytics to be performed. Hopefully, if you get a chance, you can get one of these and create something interesting. So this is another concept that we are currently working on, and we'll probably launch it Q1 of next year. And this interesting, we've taken image sensors and paired it with Bluetooth Low Energy. Typically, you don't see that combination. Image sensors generate a lot of data. That data is usually typically Wi-Fi or a wired connection is how you transfer the images. But when we talk to a lot of customers, there are a lot of use cases that came about where those use cases the video didn't matter to them. It was occasional or periodic snapshots is all they cared about. I'll give you a couple of examples. One was monitoring the greenhouse plants. In that particular use case, it was not about taking a video. It was about taking a snapshot every hour or every 2 hours just to make sure, and run some analytics on the image itself just to make sure that the plants are growing in the right fashion, the light is all okay, and the environmental conditions are okay. The other is clicking the license plate of a truck that pulls into a loading dock or pulls into a charging station. For all these use cases, all you need is a way to recognize or trigger the camera, have it capture. And a key requirement, again, is to make this as portable as possible, which means these got to be battery powered. And when you make it battery powered, energy efficiency becomes important. And that's been our focus and our goal with this sort of platform, which will allow capture of images, is to get a battery life at least a year plus on a very small sized battery. Again, this will be launched as a platform fairly shortly in Q1 of next year. It'll have some amount of object detection / image analytics running on the mobile phone. Pretty excited about this, and this kind of marries this interesting combination of the low power RSL10 we have along with some of the lowest power image sensors we have in the market. I'm not going to talk too much about this. I think Theo covered quite a lot about the switch. Hopefully all of you got a chance to look at this switch in the demo room there. I'll just like to mention that this whole concept is fairly unique, and this garnered a couple of awards for us as well. Solar sensors based, again, battery-free, maintenance-free sensing nodes. I think we already covered this. Fundamentally for us, any energy harvesting solution is a very good complementary technology for what we do. We make lowest power SoCs in many cases, and showcasing them with energy harvesting is just it's a perfect fit for us, and that's what we're trying to do here. And the energy harvesting solutions themselves are becoming mature by the day, and we do see an adoption of energy harvesting based solutions in the market going forward. So those were an example of few of the platforms we're working on, and we have launched. I'll talk a little bit briefly about a topic we did not discuss too much today, that is security. When it comes to IoT and security, they sort of go hand in hand. Every other day, there is news of some sort of a hack or another. And especially with the proliferation of IoT devices, security becomes important. Even trivial devices like things that control simple valves, it's seemingly innocuous, but in the wrong hands, really bad things can happen. Destruction of property can happen. So when it comes to security, there are sort of three high-level fundamental requirements, very popularly known as CIA: confidentiality, integrity, and authentication. So some of the couple of things you're concerned about is authentication. When it comes to authentication, is the device that you're talking to the one that it claims to be? So both sides need to agree that this is the right device, that this is the device that you're supposed to talk to. That's the authentication piece of it. Integrity and confidentiality is the privacy aspect. Is the data communication being private, or is it being eavesdropped? So, and the reason why we wanted to mention this is because we developed a proof of concept or a demo, if you will, along with our partner SecureRF. Mike from SecureRF is sitting over there. And hopefully you had a chance to look at their demo. And here's the thing that was interesting as far as this particular demo is concerned. We used RSL10, which is our Bluetooth low energy SoC, which has some hardware pieces. There's a built-in AES-128 engine. There's an IP random number generator, as well as an ability to completely lock out the JTAG port on RSL10. What SecureRF brings to the table is very unique, and it is perfectly suited for low power, low resource IoT kind of processors. So they typically, if you want to use some sort of a public key mechanism to establish authentication, ECC or RSA are fairly popular algorithms that get used on the web. But on embedded devices and low resource and low power devices, those are extremely costly, both from a memory footprint as well as the time it takes, which translates directly to the energy consumed in establishing that, in establishing authenticity. So SecureRF has come up with a proprietary way of doing a key agreement, as well as digital signature algorithms. And this bullet right here, that's the key. It's designed, their algorithms are designed for really low resource processors, and also they have their algorithms have a low memory footprint. They run faster, which means the SoCs themselves consume less energy. So please talk to Mike if that is of an area of interest, and you can get going with an SDK that they have available. Another interesting thing, like we do hear a lot of buzz about quantum computers. Nobody knows when they'll be around, when they'll come, and then when they'll be commonplace. But when we think about some of the IoT applications and IoT devices, especially in the industrial automotive section markets, these devices are geared to last for a long time. So it makes sense to make them as secure as we can. And SecureRF's algorithms they claim they are quantum resistant as well. So please talk to Mike, and hopefully you had a chance to check out the demo as well. That was a very brief blurb on security. Security is important for us, and there are a lot of SoCs as we look forward that will have security features inbuilt into them. So with that, I'll wrap it up. So basically, the basic summary is that we do have a lot of prototyping and development platforms which are end-to-end. They utilize most of our energy efficient SoCs. Most of the hardware, software, firmware is fully tested. We try to make it as near turnkey as possible. All these files, design documents, etc., they're all freely downloadable from our website. Please go and check them out on semi.com/IoT. And hopefully you can create something interesting and unique out of some of the platforms we have.